Have you ever played at Bandon Dunes on the Oregon coast? I have. When you go, there's some great links golf waiting for you. Bandon Dunes has a handful of amazing golf courses that are consistently ranked in the top 15 best public golf courses. Pacific Dunes is my favorite, yet all the courses are a treat. Did you know that more wine is sold out of the Bandon restaurants than anywhere in Oregon? I've had a few glasses of wine at Bandon. Welcome back to another episode of Polymer E Club's Ask Dr. Paul. Today we're going to talk about the original renewable elastomer that comes from rubber trees. So when your boss says natural rubber, what do you need to know? Have you seen natural rubber made from latex? The workers slit the rubber tree and collect the latex in a metal bucket. That latex is brought for processing. Essentially, you have to precipitate the natural rubber solids out of solution. Then there's a compounding step. You can put in crosslinker, colorant, filler, whatever is required to make your products. You might make tires, you might make disposable gloves. Speaking of gloves, are you allergic to latex products? It's a real problem for some. Let's take a look at the figure on our screen. We see the natural rubber repeat unit, and we've talked about it before. Carbon-carbon single bonds, carbon-carbon double bonds, methyl pendant. All that structure complexity makes natural rubber flexible all the way down to its TG, which might be about minus 60 C. The early rubber products were tacky and didn't last long. That was until Charles Goodyear received the patent for vulcanization or cross-linking of natural rubber with sulfur. That greatly reduced natural rubber's tackiness or stickiness. We also learned natural rubber struggles from environmental degradation. So light, heat, oxygen, ozone, they all degrade natural rubber like all elastomers, and we know they must be stabilized. Natural rubber being an unsaturated elastomer, those carbon-carbon double bonds, they're more susceptible to environmental degradation than saturated elastomers like EPR and EPDM. Once natural rubber repeat unit was determined, chemists tried to make it synthetically, and that's what we call polyisoprene, IR. It has the same repeat unit as natural rubber and was created in the early 1900s. So the isoprene structure and its rubbery products that it makes, they come naturally from a tree with natural rubber and synthetically what we call polyisoprene or IR. Let's take a look at the stress strain plot on your screens. When we increase strain, you can think about the natural rubber polymer chains extending. You can think about the bonds unswiveling with this strain. At some point, we get a slope change, and that's really where the chemical bonds are actually bending and the polymer chains are getting closer and closer, close enough where they actually crystallize. We call that stress-induced crystallization. So natural rubber in the resting state does not crystallize, but in the stress state, it will crystallize. There's tremendous benefits when natural rubber crystallizes for product performance. Think about a tire, think about tire tread. That crystallization improved properties like tearing strength, fatigue resistance. It's really an amazing phenomenon, really one of the reasons why tires are made of elastomers. You might notice that the unloading curve is different than the loading curve on the screen. We'll talk about that in another That's Working Knowledge video. Knowing your way around a natural rubber concepts conversation, that's working knowledge. Remember to like, subscribe, turn on notification, and even share if you appreciate the content. I'm Paul Nash for Polymer E Club's Ask Dr. Paul. Thanks for watching.